My name's Sarah Saunders. I work for a company called Capgemini, which is, we say, the biggest technology company you've never heard of. I work in the open source cloud engineering division. We used to be called the Java division, but we've increasingly found that doesn't really describe what we do, so we've made up a really vague name that can mean anything, so now we can do whatever we want. And I've been a Java programmer since about 2000, but then working for a consultancy. When I had my kids, I couldn't travel so much, so I found that I was taking on more work based on the location rather than what I wanted to do. So I was sort of saying like, oh, C#, yeah, I can do that. It's a bit like Java. And I've also been working quite a bit with platform as a service options. And this is what this talk is kind of about, working with the cloud platform as a service type tools. So for the agenda, I'm going to talk a little bit about the culture of working in IT. And then I'll make my sensationalist claim, coding is dead, that got you all in here. We all know it's not really true, but have you really thought about why that is, what our value is as developers? So we'll think about that. And then, as I said, this talk came about because I've been working with platform as a service products. And I want to talk through a couple of real-life examples of when I've been working with platform as a service tools and how I've tried to make it work as if I was working with code, and then just draw some conclusions. So it all starts here. This is Les Fontaine's, Capgemini's university complex in Chantilly, just outside Paris. It's lovely. The chateau is where all the business people go and drink fine wines and dine. And once every year they go for a week, which is called Leadership Week, and set the strategy for Capgemini for the next year. And you'll see in the foreground there's a state-of-the-art modern university campus built in the grounds. And this year during Leadership Week, I got to go along as part of a hackathon which was being held in the campus. So while all the suits were wining and dining in the chateau, here's a picture of us all. We were all down in the campus. They gave us these lovely brightly coloured t-shirts to wear, and we were coding 20 hours a day on a hackathon project. The concept was build an app that might help VIP airline clients. So they said, for example, your client is Rihanna. She has a private jet. She's flying around the world. Can you build her something to improve the security on her private jet? So there was us having fun. But we didn't get away completely. We did get dragged into the chateau at one point, and the guys in suits sat us down and they said, you're different. And we said, well, you gave us these t-shirts. But it turned out that wasn't what they were talking about. They were talking about the way in technology we have this culture of sharing, which doesn't exist in other parts of Capgemini. If you think about, if you got stuck writing some code, you just go to Stack Overflow. You'd ask a question. People would fall over themselves to give you an answer, to improve on the answer, to correct other people's answers. We share and share our code and our data. Every single piece of code you could ever need to write is probably out there on the internet. All you need to do is ask for it, and people will give it to you. And other divisions within Capgemini do not have this mentality at all. In the sort of business process division, if you were being asked to choopy across a team from one company to another, and you'd found a really good way to do this, you would keep that knowledge because that knowledge is your value to the company. You know, most people in Capgemini, on their C drives will be all this documentation of how they do their work, and they will not share it. And the question was, well, why? And we thought, yeah, that is a really good question. Why do we share so well compared to other industries? And we use quite a lot of sort of gamification techniques with Stack Overflow. You know, you get points for replying, so you do get something, and that thing does have value. If you were going to submit your CV, you would put your open source credentials on, you would put your Stack Exchange credentials, and people would pay you more because they can see that you contribute to the community. So it does give you value. There is a value in this sharing. But this doesn't translate to other communities because, as I said, their knowledge is their power. But for us, just because we know how to write a really efficient loop, so does everybody. You know, the actual value of the code itself is really low. And that leads us to quite a scary conclusion. You know, if the code that we write has no value, then are we, as developers, a valueless resource. You know, should writing code simply be a luxury, or you know, are we out of jobs? So just to break up the talk a bit, I thought I'll do a demo. What could go wrong? So to support this hypothesis that we don't need to write code anymore, I want to do a quick demo of this product called Mendax. Has anybody ever heard of Mendax before? No. So it's sort of platform as a service. It's a Scala platform. You can install it locally, but mainly it runs in the cloud and allows you to do rapid application development, mainly designed at sort of websites, you know, enter some data, store it, do a bit of business logic, report on it, that kind of basic flow. And so it's drag and drop development of these websites. So I'll attempt to show you it. They do have a browser-based version, but it's in beta, and I thought it was risky enough trying to do a live demo without doing a live demo of a beta edition. So they have a Windows version of their IDE that you can see here. So basically, first you go to their website, this application platform, and you create a new application just by clicking on the button. And then you can choose a starting point, so a template, a blank application. They've got a few examples. It takes a little while to load, so I've preloaded one. And then you download this modeler tool, and this is a basic website one. So the first thing that I might want to do is create a data model. So to create a data model, you just drag your entities onto the screen. So say I wanted to do an employee database, so we'll create a table called employee. And then you can add some attributes, so they might have a name, they might have an email, phone number. There's a few slightly more complex things you can do. So I could choose that this data type is going to be an enumeration called level. And then I can specify what the values are of that enumeration. So you could maybe be a junior in the company, or you could be an associate in the company, or you could be a senior. Okay. I should call it level, shouldn't I? So there's our employee table, and then maybe I want to have a department table. And a department would just have a name and a description. You see, there are other data types if I wanted to do dates or other things. And then if I want to create relationships between these tables, I can simply just drag it, and that will create me the relationship. It's defaulted there to many to one, which makes sense to me. So the kind of stuff that you would do in basic SQL is easy to reproduce. And then pages are easy to create as well. So if I add a new page, it gives me a choice of templates. So this sort of master detail one that has a list at the top, and then when you click on the list, you'll get the details. And then I might want to link this grid to my employee. So I've got this connector here. I can just drag the employee over, and it will automatically populate the columns of the list so that I can update that. So fairly straightforward. The thing that I like about it is you can add business logic. So if I add a button here, if I want to add a promote functionality, so I'll create a new button, call it promote, and then I say when you click the button, I think I've done that wrong, delete that one. It's an action button I want to add, promote. And then I can say, when I click it, call this concept called a microflow. And I'll say I want to create a new microflow called promote employee. And then if I go to that microflow, then you get this kind of business logic drag and drop screen. So I can say things like, I want to do an exclusive split on my employee based on their level. So they can be junior, they can be senior, it was junior associate or senior, or it could theoretically be empty. So I'll create the possibilities, and then I can assign these possibilities. Yeah, I'm trying to. Oh, I have to say what I'm doing, don't I? So I have to say I'm splitting on the employee level. And because that is an enumeration, there's a finite number of options, and so it should let me use this exclusive split. So I'll say that was for junior, this is for associates, and this is for senior. And that would be empty. And I can do, how do you promote a junior employee? Well, you change their status. So I can do a change object activity, and I can say you're going to change this employee variable. You're going to change the level attribute to be an associate. And there's that flow is built in. So I won't bother doing it all, but you get the idea. It's not super powerful, but for sort of 70% of your business applications, you could probably reproduce what you wanted to do fairly quickly using this, and you haven't written any code. And again, it takes a while to launch up because I've just got the free version here, so it powers it down every time you stop using it. But you can see what it would look like. It's nice. They use Bootstrap CSS, so it looks fairly modern. And then you can just see that if I promote myself here, there we are. That's better. Oh, I'm already at the senior. So it's quite nice. And as I said, it's actually a Scala platform. So what I've written here is a responsive Twitter Bootstrap CSS Scala application. And it didn't take me very long at all. So I'll go back to my presentation here. When you show this kind of thing to CIOs, CTOs of companies, they say, well, hang on a minute, that looked really easy. Why is it that we're paying for all these super expensive developers when, as far as I can tell, a baby could have built that application? And this is where we all put our head in our hands, you know, because we know that our job is not about coding. I think there was a survey that kind of evaluated exactly how much time developers spend writing code, and it's something like 8%. And it's not because we spend the rest of the time at the coffee machine, it's because most of what we do is around the development life cycle. It's about defining what we want, it's about communicating with our clients to realize that, it's about working sort of cyclically through in this agile way to make sure that the client understands what it is that we're building for them. It's about building our continuous integration pipeline. It's about automating that so there's no room for human error. It's about all the different types of testing, unit and user and performance and so on. But the CIO doesn't see that. They see some guy from Mendax come in and build an app that seems to work and seems to be deployed to the cloud in about 30 seconds. And they start to question our value. So I went to a sort of meetup event. It's called the Mendax Tour, and it was around Europe, I think, people who had had good experiences with Mendax coming to showcase what they built. And it was a lot of CTOs of small companies, and they built prototypes really quickly, and they were talking about them. And it was quite interesting listening to them talking to each other afterwards. You heard a lot of these kind of phrases, nobody can touch that, it's mine, or I wish people would stop tinkering with it, or, you know, people have broken this. And this isn't because Mendax hasn't provided the concepts such as version control and teams and versioning of the product. They're all there. Mendax will give you a team room, it will give you support for stories, it will allow you to grant permissions across the code, but of course these people don't realize what those concepts are for or how they can use them. So they just go straight to the business modeler, put in their business logic, and then complain when somebody else comes and alters it. So we in technology, we know all these problems because we've seen it all before, and you know, we're sitting there with our head in our hands watching non-technologists repeat the same problems because they think it's all about the code. So you know, it's not all about the code. Our career and our subject isn't dead. But it may be that you're asked to work on a platform as a service project, or it may be that you hear that your company is running one and not within IT because they don't think there's any code. And you have to think, how would you run a platform as a service project? Because you still want the same end result. You still want to build, test and prove something which is going to run business logic for your clients. You've still got a deployment unit that you want to put into environments. So how can we apply the knowledge that we have about code to working with these platform as a service products? So I've just got 2 case studies now of a couple of tools that I have worked with and what I learned along the way using them. So the first tool is called API Connect. Has anyone come across API Connect from IBM? It's an API management tool. So it's got sort of 2 use cases. One is you've got your microservices and you want something to help them communicate and to expose them. And then the second typical business model is a client has a lot of legacy systems and wants them to look fresh and modern, so wants to expose them as RESTful APIs to the public. So they put this API management pipe layer in between, and what it can do is it can alter the structure of existing APIs. So you could take SQL from your database, combine it with a SOAP service, and expose some JSON, things like that. So again, it's a drag and drop interface. You say, I want that bit of data and that bit of data. You enter your configuration, and then you deploy to the cloud. So when we were implementing it, we decided that, okay, this isn't code, but we're going to run this as a code project. We still want assurance that it works. We want an agile project structure. We want sprints. We want to be able to release every 2 weeks. We want automated deployment. And there are a few interesting issues that we came across as we were running the project. And the first one was this concept of environments in the cloud. We created 5 environments to match their 5 internal environments: dev, sit, UAT, pre-prod, and production. And of course in the cloud, these are identical. That's just a label, it's just a name. They've all got the same hardware underneath, they've all got the same internet exposure. But because this one was called development, people started treating it, oh, well, we don't need to worry about, putting security on the development environment because, there's no data in there. And you're thinking, you just put all your business logic in here. You can't leave it open to the world. But because it has this name, test or development, people didn't treat it the same way. And the second issue that we had kind of also links to this concept of environments, which was deployment. What is our deployment unit? If you think about when you're writing code, if you had this environment set up, in your development environment, you'd write some code, you'd run your unit tests on it, and then you'd have a configuration file of some sort which would tell you which underlying APIs, the test APIs you're pointing to, and the test database credentials. And then when you move to sit, you would change that configuration file to point to all the sit data, but your business logic would remain the same. So you'd move a chunk of unaltered code into sit. But with API Connect, we were effectively building a pipe. So the only thing that changed was the configuration of what it was that we were actually talking to underneath. So if you're changing everything every time you move between an environment, and you've got to question the point of having all these environments. So what I wanted to do is this setup. I said, well, there's no point in having a development environment if it's just a pipe, because in development, you should be mocking up your endpoints. You shouldn't need it. So, okay, have a sandbox, have a play with the tool, but don't link it to any internal environments. And then in sit, I can see the point of linking through to your internal sit environment, because you want to do some load testing and you don't want to alter the environments that your clients are using. So fair enough, in sit, point to your internal sit APIs, and then change all your configuration and move to UAT. But from UAT, you want the users to be pointing to the production systems, because you've built a pipe and the users need to know that that pipe points to the production systems. And I failed to get this through to the client. He was like, no, we can't have production URLs anywhere except in production. So I don't know. I didn't go through this slide with him enough times, I don't think. But then from UAT, you can practice moving your production configuration between environments. So you move it to pre-prod, and you say, okay, have I successfully moved that? That's your test. Yes, okay, that's fine. Then you would move it to production. So all of those 3 environments, I felt, should in theory point to the internal production systems. But as I said, no luck with the client. And then the third interesting thing about platform as a service, API management, development, is what it is that you're actually testing. because you've built a pipe, it's quite difficult to not end up testing the underlying systems. You're not in control of a lot of the code, so there's no point in testing it. You know, we didn't want to be testing the API Connect platform because we were hoping that IBM had done that for us, and we didn't want to be testing the internal systems. So it was quite difficult to define what our test criteria should be. So in the end, we came up with what we need: a successful test, and the definition of that is some data's gone in and some data's come back. We don't care what data went in, we don't care if it was gobbledygook, and we don't care if we get back an exception. All we want to know is that the pipe has gone through correctly. And then there's the sort of security side. What happens if I use invalid credentials? What happens if most of my URL is correct, but I've stuck the wrong bit on the end of a RESTful URL? You know, what will happen? What happens if the credentials are valid, but I'm not actually permissioned? So these are the tests that we defined as valid for API management. And now this is the second platform as a service type tool that I worked with. Again, it's from IBM. It's called Cast Iron. IBM bought Cast Iron basically just to remove a competitor from the marketplace. And I don't think they really know how to position it with their existing tools. We thought it was brilliant, a really, really good quality tool. I've got a picture of Marvin here because it had a brain the size of the planet, and we just used it as a pipe, which was a shame because it was a really good product. It's hardware backed, but IBM had chosen to deploy it to the cloud and have it as a cloud offering, which kind of limited how we could use it. But basically, it did similar things to API Connect and then a little bit more. So you could create a data flow from some input, you could munge the data, add to it, perform some calculations, and then you could output it to somewhere. I've got a few screenshots from the IDE to show you the kind of things you can do. So again, it looks a little bit like Mendax. You have a flow, you drag in the pieces that you need, and they can do these various different tasks. So there's built-in connections to everything that you can think of. And then it had a little bit more, because it has a variables tab, so you start to get the concept of state, activities that were already built in, so that saved you a lot of time in transforming files, reading different file types. And there's a functions tab as well, so things that you might have considered you'd need to write in code, you could kind of drag and drop variables and combine them with these functions. You could even write custom JavaScript as well, so you could get a bit of code in there. And again, we came across a kind of fairly standard set of platform as a service issues when we were trying to use it as a development tool. So the first issue is security. Because IBM had deployed this to the cloud, there was just one way that you could secure your API connections, which was basic authentication over HTTPS, which is fine, really. Most banks use that successfully. But you know, it's interesting that there is that massive limitation. And we had quite a few long conversations with the security team who were saying, well, it's okay because we'll IP whitelist the incoming IP addresses. And we're saying, those are the IP addresses of a cloud. You know, just because you're restricting it to only people that can develop in this cloud doesn't really help your security model very much. And then the second issue that we had was around versioning, because we wanted to be sure that we could say, you know, which version of these flows that we were building were in which environments. And Cast Iron tool provided a couple of ways to do that, neither of which really helped us. One of them, every time you made any little change to the flow, it would create you a new version, and they just proliferated. We ended up with hundreds of them. So in the end, we created our own version control strategy, just using the name of the flow, and then we saved it to our own Git repository, because what was on offer didn't really work for us. And then we came back to this issue of how to test. Again, what are we testing? We're testing the pipe, not the data underneath. What's the scope of application versus integration testing? You know, we wanted to write unit tests, and we wanted those unit tests to be automated in our continuous build pipeline. But how could we mock up endpoints for the cloud and create some kind of valid test? there's no JUnit here. We had to write it ourselves. So we ended up with quite a lot of custom Python scripts. We were slightly fortunate in that cast iron has a management API that we could call to do things like deploy these flows to the cloud. So we were able to build a continuous integration flow, but getting the unit test piece to sit in was quite difficult. So yeah, sort of sitting back and reflecting on the projects, I was thinking, okay, there is a kind of pattern here. There's reuse in some of the work that I've been doing in both of these projects. And as I said, we want to run these like we run projects where we write code, because we know that we've learned so much about the software development lifecycle. And just because you haven't written the individual lines of code, the same concepts are here. But there are subtle differences in the definitions. So I thought, okay, well, maybe I'll take on this job of trying to set up a platform as a service project run book with some overall, best practice and guidelines for how you might make this work. So if you had a standard sort of sprint, you want to design, build, prove it, and then you want that to continuously be released onto a platform. At the design and planning stage, with a platform as a service product, I think the two main things that you've got to look at are security, because you're most likely in the cloud, and the limitations of the product. Does it have a management API? Does it have security restrictions? Because if those don't meet your requirements, then it's game over. You're not going to be able to get vendors to change quick enough, and you need to realize that as soon as possible. When we were working with cast iron, we just had to go straight to the security architects and say, if HTTPS and basic auth is not good enough for you, then let us know now before we waste money on license fees and so on. So in theory, the test and build phase should be very easy with these products, because it's just dragging and dropping. And as I mentioned, sort of the interesting points are, how can you create a unit test when you don't have any code? So sometimes that won't be thought of by the PaaS vendors. So something extra to look at. And then the proving test, the integration phase, as I said, what am I testing? How can I test it? You need to come up with a specific list of things that you actually can test, and make sure that it's code that's under your control, not the platform code and not the underlying product. And again, product limitations might affect that. The documentation phase should be pretty easy. Most of the tools, because they're already auto-generating code from boxes, they can also auto-generate the documentation. So all of the ones that I've worked with have instantly offered you Swagger or YAML or WSDL for the APIs that you create. And then the continuous integration phase, again, is very much product dependent. Is there a command line interface or an API that you can use to automatically deploy these products, or are they expecting you to actually be on a browser and click and drag and drop? Flow monitoring, if it's not built into the product, then how on earth are you going to monitor it? What we found with cast iron is that they had a monitoring API, but it actually only monitored the management platform itself and not the individual APIs. So what we had to do was build a little pinger for every single one of our APIs, and we had to build an API endpoint so that we could say, are you there? And we get a yes back, versus a proper call which would trigger the logic. So it was actually, quite a big deal. Probably more work went into the monitoring piece than building the rest of the application put together. And then there's the joys of support when you're working with a platform as a service product. It's like in The Simpsons, where Homer Simpson's working with his radioactive green stuff, and he's got the big gloves on and he can only move it a little bit. You kind of feel like that. You feel really restricted. If I could just get that log file, if I could just reboot that, then maybe, but you can't. All you can do is open a support ticket and wait for the 24-hour SLAs. So there is a lot of being zen involved in working with cloud products. And during one of these waiting points for a ticket, I was kind of musing, you could probably track the point that a client is at with a vendor's PaaS product against the number of tickets that they open. Because when you first get the product, you might get really excited about it and you'd use all the functionality incorrectly. So there'd be a great glut of tickets, which are all user errors, basically. And then when you've built your application and you get to the sort of performance testing piece, you get a smaller subset of tickets, which are actually genuinely serious tickets that take a long time to close because you're pushing the product to its boundaries, and you need to get IBM involved. And there was an interesting, well, a different set of tool sets that we used in these projects, and they were the same in all the past projects that I've worked on. Soup UI and Postman, I'm sure that you've come across both of them. They were both invaluable for unit testing, especially Postman. We could script a whole Postman set of requests to run and record the results, so we could automate that beautifully. And these tools, HTTP bin and request bin, they're a page where if you call it, it will print out what you've called it with. So if you're building a pipe, it was super useful to send the pipe to HTTP bin, and then we could look at what we'd actually sent, which would help with debugging when we send to the underlying systems or to the clients what it was that we'd actually sent. And then we did a lot of conversion between different data types, XML and JSON. So we did a lot of XSL parsing. And we used this, we actually even bought a license for this XML Spy product because we found it so useful in doing the conversion and validating the conversion between data types. And then, as I said, for the unit testing piece, there isn't much to help you automate. So we wrote quite a lot of custom Python scripts to test our APIs and make sure that they were working. So that was as good as we could come up with on the test front. So you might think with this platform as a service, isn't it the same old buy versus build argument that we had, forever in the 90s with custom off-the-shelf products? Either you write the code yourself or you buy it, and the trade-offs are fairly obvious. And yeah, I think it kind of is, but I think because of the way we develop these days, the criteria and the parameters to the argument have changed. Back in the day, if you bought an off-the-shelf product, you'd be really dependent on the infrastructure it ran on. You'd be really dependent on the vendor themselves still being around, and it wouldn't be that customizable. Whereas if you look at Mendax, it's super customizable. And if we're deploying to AWS or something similar anyway, then we've already got that vendor tie-in. So it's not such of a big leap to say, oh, well, let's go with Mendax instead of AWS, because you're still relying on the existence of a vendor. It's just what they're providing you with. And I also think we've got a better understanding of application lifespans now, because if you're saying back in the 90s, oh, I still need this vendor to be around in 20 years, I think now we've got a better understanding. A lot of the business applications we build may have a lifespan of 5, 8 years, so it isn't such a massive leap forward to see whether a company, like Mendax would be around in 5 years' time versus 20. So, in conclusion, I heard the expression from Gartner that the citizen developer, these tools that can be run by the citizen developer, which is, it's been said before, hasn't it? And I think they think that there's a new generation around, so they can get away with saying it again. These citizen developer projects need developers because you still need an understanding of the overall software development lifecycle to get the projects to scale up to an enterprise level. Yes, you can produce a proof of concept, but it's not going to be that useful for your business without this great platform of support that we provide. So I think the conclusion is to realize that your strengths are not just in the code that you write. In fact, that's you probably do that for fun. When I first started working, I joined an investment bank and I joined their graduate scheme, and they had 3 tracks. You could either go down the frontline support track, or the kind of working with vendor products track, or the software track. And I wasn't that sure about which one, but I ended up on the software track. Day 1, we had to learn C++. And he wrote this on the board. See if I can get the syntax right. I haven't written it. While something like that. Can anyone tell what that does? Yeah, it's an array copy. So you've got a pointer here and a post increment, and you're assigning it to another memory pointer. So if you've got a bit of memory here, and a bit of memory here, so this is pointing to this, and you're saying assign that to there, and then you're incrementing it, and then you're saying assign it to there, and then you increment. So you've copied an array. So it's the most beautifully unreadable code. And I thought, yeah, I've chosen the right track. You know, this is a puzzle. This is fun. Mendax is, yeah, it's very practical, very quick, but it's not what I want to do. I want to write code because I enjoy it. I enjoy the puzzle and making something beautiful, which, okay, I might have copied most of it from Stack Overflow, but I can feel that it's my creation. And I think unless we adopt platform as a service tools, their implementations are going to fail. So it's really kind of down to the developer community to decide, is it in our interest? Is it worth our while? Is it something that we want to do? So I'll leave that thought with you. And thank you very much for listening.